So this is the 2016 Leaving Cert Ordinary Level Paper 1, and we're looking at question number 2. Z1 is equal to 1 plus 3i, and Z2 is equal to 2 minus I, where I squared is negative 1, and these are two complex numbers. So we have our two complex numbers here, and then we have I squared is equal to negative 1. Part A says, let Z3 equal to Z1 plus twice Z2. Find Z3 in the form A plus BI, where A and B are elements of the Z set. Now the Z set is the set of integers. So we're going to set this equation up here. We're looking for Z3, so Z3 is equal to Z1, which is 1 plus 3i, plus twice Z2. So plus twice Z2, which is 2 minus I. So we're going to tidy this up a little bit. We get 1 plus 3i. And we've got to multiply this out. 2 by 2 is 4. And 2 times minus I is minus 2i. So going one more step, we've got 1 and 4, which are the real parts. They combine to give me 5. And then you've got plus 3i minus 2i, which gives me plus 1i or plus I. So we have Z3 there. Part B says plot Z1, Z2 and Z3 on the given Argand diagram and label each point clearly. Okay, so Z1 is 1 plus 3i. So we go over to 1 on the real axis, up to 3 in the imaginary, and there's Z1. Z2 is 2 minus I. Now 2 minus I is just the same as 2 minus 1i. So it's 2 on the real, down to minus 1, and that's our Z2. And finally Z3, which we just established, is 5 plus 1i. So that's over to 5 and up to 1. And there we have our Z3. Okay, so part C says investigate if Z2 minus Z3, the modulus of Z2 minus Z3, is equal to the modulus of Z1 plus Z2. So we'll set this up again. We're looking for the modulus of Z2, which is 2 minus I. Subtract Z3. So when we're subtracting, we've got to protect in brackets. Minus Z3, which we just established was 5 plus I. So 5 plus 1I, or 5 plus I. So we're looking for the modulus of that. Is that equal to the modulus of Z1 plus Z2? So Z1 is 1 plus 3i, and then Z2 is 2 minus I. So 1 plus 3i plus 2 minus I. When we're adding complex numbers, we don't need to protect with the bracket. So now we're going to tidy up. The left side here is the modulus of 2 minus I. Now minus by 5 is minus 5, and minus by plus 1i is minus 1i or minus I. So that's equal to the modulus of, I'm going to tidy up here, I've got the 1 and the 2 combining to give me 3, and I've got the 3i minus I here giving me 2i. Tidying up this side, I've got the 2 minus 5, which is negative 3, and then I've got minus I, which is a minus 2i. So we're seeing, is that equal to the modulus of 3 plus 2i? So as we can see here, the numbers are the same except for the signs. There's minus 3 here, plus 3 there, minus 2 here, plus 2 there. But what is the modulus? Well, the modulus is the distance from the complex number to the origin. And the way we can find this algebraically is by using Pythagoras. So the frame for this would be square root of the real part squared plus the imaginary part squared. So we've got minus 3 here, we've got minus 2 here, we've 3 here, and 2 here. And when we work this out in our calculator, we get root 13. On this side, we also get root 13. So, yes, they are equal. Our investigation is done. Okay, so finally, part D says find the complex number w such that w is equal to z1 divided by z2. And again, give your answer in the form a plus bi, this time where a and b are elements of the real set of numbers. So again, we'll set this up. W is z1 divided by z2. So z1, if we remember, is 1 plus 3i, and z2 is 2 minus i. So we have 1 plus 3i divided by 2 minus i. Okay, so when we're dividing complex numbers, what we must do is multiply top and bottom of the fraction by the conjugate of the bottom. So the conjugate of the bottom, if we have 2 minus i, the conjugate of the denominator. 2 minus i, the conjugate of that is 2 plus i. You change the sign of the imaginary part. Whatever we multiply the bottom of a fraction by, we must do the same on top. So you got to multiply the top by 2 plus I as well. So we're going to multiply out the top and bottom of this fraction. 1 times 2 is 2. 3i by 2 is 6i. And then here 1 times I is 1i. And then finally this here, 3i times I is 3i squared. That's all going to be over 2 times 2, which is 4, minus I by 2, which is minus 2i, 2 times I, which is 2i, and finally minus I times plus I, which is minus I squared. So when we're tidying this up, we need to bear in mind that I squared is minus 1. That's the definition that was given to us at the beginning of the question. So we're going to tidy up as best we can here, keeping that in mind. We've got on top, we've got the 2. Now 6i and 1i on top, that becomes 7i. And then we've plus 3 times I squared. Now I squared is just negative 1, as we know from our definition from the beginning. Underneath here, we have our 4. Minus 2i and plus 2i combine to give 0. So you're left with 4 and then the negative I squared. So to tidy up further again, on top you have 2. Now 3 by minus 1 is minus 3. So 2 minus 3 is minus 1. We still have that plus 7i. And underneath here we have 4 minus I squared, but I squared is negative 1. So this is giving us minus 1 plus 7i all over 4 minus minus 1, which is 5. So we're almost there. We just need to give it in this form now, a plus bi. So we can split the numerator now with the denominator. So that becomes minus 1/5 plus 7/5 I. Minus 1 over the 5 and then the 7i over the 5. And that's our answer in the form that we're asked for. And that's the end of question 2.